Hi everyone, it's Ashley Diet with Healthy in a Hurry Essential Oils. I'm just going to wait a minute. I went ahead and started about a minute early. I want to make sure that everyone can hear me. I am in a different place doing this today, so I want to make sure that it sounds good. I know I look super washed out and it probably looks crazy. It's pretty hot here in Virginia, and I am actually here today from a coffee shop in Portsmouth. So I'm going to be recording this call outside. I felt like it was a little loud inside and like you couldn't necessarily hear me. So please let me know if you can hear me and you're on this, and I will go ahead and get started. I am very excited with what I have to share with you all today. I think the best part about it is that I am not a scientist, and I have learned all this stuff on my own, and you can do the same thing. So I want to be encouraging and tell you to make sure that you are able to do your own research, and that you are, obviously being someone who learns and is a student of all, natural wellness practices, and also a really your own student of science, that you continue learning and growing as a person wherever you go. So I'm going to go ahead and tell you I will be using a script today, and I probably will mess up on a whole lot of words. So bear with me and know that I am an amateur. I'm not a scientist. I said that and I'll say it again. And also I am here again on my own as Ashley Diet. I'm not here as a doctor. I'm not here to treat, diagnose, prescribe, or cure. I'm simply here to give you some education and information about the science behind essential oils and some of the constituents in those essential oils. I'm going to go ahead, and I think some people, just want to make sure someone could hear me. All right. All right, so first I want to start with plants have similar cellular structure to what we have. So I want you to picture a cell, and a lot of times you picture that cell membrane, the mitochondria may be floating around, but definitely the cell nucleus. And there's all kinds of micro machines inside of our cells that make us work efficiently and operate in a way where we can process information and communicate back and forth. So plants have similar cellular structure, except for they have a cell wall. That cell wall is impermeable, and what that means is that everything that they're protecting themselves from within that plant cell, they're going to have to block it out, okay, because they cannot process that information or those nutrients or anything like that. So we're not going to go too into detail, but I want you to really think about that and how that structure is so very different. So where in the world do essential oils come from, and what are they? So I know what you're thinking. A lot of you guys might already have your own definition, and I'm not going to redefine in your head what you necessarily think they are. But what I will tell you is that the easiest way to look at what they are is not to just say they're the lifeblood of the plant, but look at all the good things the plant does. It's like like a human cell or like a human body, except for we're actually going to take out the emotion in the general nervous system. So really what essential oils are is that they're all the goodness in the parts of the plants that actually restore, regenerate, and protect the plant. So in order to make those essential oils, so that's the first part of this real science we're going to talk about, is that in order to make those oils and get them from a plant, we actually have to distill that plant material. So you couldn't like simply in your house take it and basically, take a, I don't know, what am I around right now? Well, I don't know if I can get oils from any of the plants around me, but let's just say I had maybe peppermint growing right here. I couldn't just take the leaf and squeeze it and I would get peppermint essential oil. I'm going to talk a lot about distillation and how it's actually a physical operation used to produce, isolate, or purify a substance. So in order to distill a liquid, in order to distill a plant, a liquid must be brought in, and it must be brought to a very rapid boil. And that's something that I'm, as a student of distillation right now, it's something I've been reading a lot about. And again, not an expert at all. I've been studying and really learned that you have to use a huge amount of water to get a very small amount of essential oil. So in order to distill a liquid, it must be brought to a boil, and a rapid boil, and a sustained boil, and the resulting vapor, so not even the material or the plant material itself, but the vapor is then led to a condenser. That condenser is where the molecules collapse back into a liquid form. So you have a bunch of plant material, and you're going to put it in some kind of cooker. then you're going to add a large amount of water, and then you're going to make it boil. You're going to hold that boil at a rapid rate. Then once that boiling substance, it's different point for all different plant materials, but once you've got it to a point where you're actually going to have that vapor that would be the amount they're looking for, and that's a whole other organic chemistry piece of information about the quality of the vapor. But that vapor is going to be led to a condenser. In that condenser, so I picture mostly glass. Glass condensers are what are used in most essential oil distilleries and manufacturing operations, and that's going to come together, and it's going to reintroduce itself in a liquid state, and that liquid form is the actual essential oil. So essential oils, yes, they are the lifeblood of the plant, but the way they are produced is relatively complex and cannot necessarily be done, if you're someone just on a whim grabbing a leaf out of your yard. So I want you to think about that. And that large amounts of water, and the amount of water and the amount of pressure and the time in which it takes to actually cook down that plant, those are all three different indicators of quality. And I think that's pretty interesting. We're not going to go into grades of essential oils. That's something I'm definitely not knowledgeable about and an expert in. I would say I'm not knowledgeable. I'm just not an expert in that, and that's not something I can introduce to you as an elementary part of this science. But with that, when you have pressure, the pressure in which the plants and the water are under can drastically alter this equation and the time it takes to complete the distillation process. So the more pressure that you put onto the plant material, the quicker the distillation process, and the lower quality you actually get from that vapor that recondenses and forms the liquid, which is the essential oil. And the lower the pressure in that cooker and on that water, then the higher quality, because then the more amount you get out of the actual plant material. So how in the world do you know what is in an essential oil? So this is going to sound silly. Maybe some of you guys are like, oh, I don't believe Ashley, but I didn't know what this was. Like, I literally, probably until, 6 months ago, did not understand what a GC was. So I understood what was important, but I want to tell you what it is. So a GC refers to gas chromatography. And this is something, if you Google like gas chromatography, you'll come up with all kinds of interesting, and yes, I'm bringing Starbucks, and yes, you'll come up with all kinds of interesting information about different companies that offer that, mostly to pharmaceutical companies to actually test their products. This is a very important method that's actually used to characterize essential oils. So the peaks of the GC, and the GC, I want you to all, I'm not going to put a picture on screen share, but it actually looks like a giant, let's just say a giant blank paper. It has peaks and valleys, and each peak would represent an amount of a certain constituent in that one drop of oil that's tested. So each one look different depending on the conditions of the soil, where it's grown. So not every drop of oil is going to be the same. Not every oil in general is going to be the same. So GCs can actually be used to determine the actual concentration of each constituent that's in the individual oil. So it can reveal these constituents, show what's in it, what might be missing from a certain type of oil. So what I'm going to do now is I'm going to tell you a little bit about the difference between a GC and then what we call the mass spec, or the GCMS. The GCMS is really what is used most often to really look at that mass spectrometry, and what's used with the GC to aid in determining if any adulterants are in the oil. And I think that's so interesting because I have just learned a lot about how much the cosmetic industry and other industries use essential oils, and they adulterate them to produce more of them, especially when we look at things that are going to be like phenols and esters and menthols are used in all kinds of commercial products. And they're mostly used in a way they're going to adulterate the substance and add and introduce chemicals into that natural drop of oil to actually make it go farther and make it be cheaper. So it's pretty interesting because that mass spectrometer, it ionizes the compounds. And so when it ionizes them, it makes them easy to measure. And it sorts them out by their mass to change ratio. And that means, right, am I just getting way too sciencey here? I feel like I am. So their mass to change ratio would be, the amount of matter in it and how quickly it changes. And they're measuring that according to their molecular weight. So molecules weigh, nothing in terms of comparing it to pounds. I want you to think about very tiny things and how they can be weighed and evaluated. So the results are then charted. So GC, you get a chart. The mass spec, you get a chart. So these two charts are what together are really going to determine what is actually in that essential oil and if that essential oil molecule has been adulterated in any way. I totally veered from my notes, so hopefully I'm still giving you all the information that you are here to hear today. So a couple other things about those wonderful testing mechanisms. So most testing is going to be done in a very controlled environment for essential oils. So we're going to picture a lab. So yes, it's natural plant material. It's going to go through a distillery, and it's going to be tested in a lab for purity and quality, just depending on the company that's making it or who's actually studying those oil molecules. So I hope that gave you a little bit of background. There's tons more we can discuss. I'm going to do that in my next segment or my next chapter of this journey about learning about science. But now I'm going to go into something that I'm intrigued by, and that's something called functional groups that are within essential oils and found naturally occurring in essential oils. And then we go into some of the constituents, which the constituents are mostly part of the functional groups. So the functional groups are simply put together that produce a certain effect when they come together. So a functional group would be something like looking at the structure of water. That's a functional group, okay? Hydrogen is more than just one molecule. If it cuts a couple together, that's going to be a functional group. So first we're going to talk about phenols. So phenols are actually the term for a class of compounds in which an alcoholic hydroxyl group, so that's one group, and they attach themselves to an aromatic benzene system. So the system is a couple groups put together. Those two things come together, and that happens very rarely in nature. Okay, so the two times it happens in nature and within the essential oil realm are really with thymol and carbachol. So those are two constituents that are found naturally occurring in some essential oils. Thymol and carbachol, and they have the properties that are very antibacterial and antiviral, but then they also are slightly irritating to the skin. Okay, so that's kind of how they manifest themselves and the things that are most common in those two constituents. These also, phenols, don't occur very often in nature. They are mostly man-made and manufactured, and some of those things, like I was saying, in cosmetic products and the pharmaceutical industry, phenols often represent themselves to possess those qualities within those two realms. So the next thing we're going to talk about is the word that I'm telling you, I mess up this word on a daily basis. I am terrible at it, but I'm going to try it for you. So sequester terpene. So this group of compounds are not widely recognized outside of the aromatherapy realm, but they have so many constituents within this. This is a huge category, a huge class, that are not even reported and documented because they are so unique and complex. So with this, not widely discussed at all in the pharmacological realm, but okay, I'm going to spell it for you. It's chimazulene. So chimazulene is one of the more well-known constituents, and so that constituent that's within that sequester terpene realm is known to be very soothing, anti-inflammatory, and anti-allergic qualities. So also within that realm of sequester terpenes, we have caryophyllene. So caryophyllene is actually something that has strong sedative qualities, and it actually will negatively affect viruses. So that's a pretty interesting thing. And some of these oils that, just oils in general, can have up to 50% of their content can be with sequester terpene, hydrocarbons, and the general property of those in that group is that they're anti-inflammatory, very cooling, and very anti-allergic and soothing in general. So it would be cooling to the body and also cooling as in with heated emotions. So the next group that we're going to go into, this one's so fun, aldehydes. So pretty interesting about aldehydes and that just word in general. So aldehydes are responsible for fragrance. So fragrance in general, and not just used in the essential oil for our therapeutic grade essential oils. This is going to be something that's used for fragrance in a lot of cosmetic products, a lot of things we use in general around our homes and around the world. And these possess, for the most part, very strong antiseptic qualities, are calming, and then they have anti-inflammatory properties. Those are aldehydes. And aldehydes, again, are a relatively large grouping or large group of compounds. But then we're going to talk now about terpenoid compounds. They are under the aldehyde family, but they're very specific, and they are usually under the names of citral or citral. Yeah, that's right. So those are going to be things that are used most often that contain aldehydes and terpenoid compounds. Terpenoid compounds will be less irritating to the skin. Ketones. I thought this was fascinating to learn about ketones. So the word ketone is actually derived from the popular word acetone. So all ketones, they share that same functional group, and that's the ketone or the carboxyl. So we talked a little about hydroxyls. This is not hydroxyls, this is carboxyl group. And the most prominent feature of all ketones, so ketones are again a big functional group of molecules that can be found together in compounds. But the strongest and most prominent feature in them is their mucolytic effect, or their ability to stimulate and then liquefy mucus and cause it to be secreted. They're also great for wound healing and the regeneration of new tissues in general. We're going to go next to esters. So esters are actually formed by the reactions. They're not even a naturally occurring substance. The reaction that occurs when you have alcohols and acids, and then they're put together. So the resulting compound is actually very fruity and fragrant to your olfactory system. And this is mostly used in edible food items and aromas that are going to be pleasing to your senses. So they are electrically neutral. And that does not happen, again, very often in nature. They're electrically neutral, and they're used for soothing, balancing, and antimicrobial. They're also negative against yeast and other candida and fungi, and they are soothing to the skin, and there's direct action immediately upon usage on the CNS. What's the CNS? Anybody? I'm sure someone out there knows what it is. I know y'all can answer me, but we'll pretend. So the CNS is actually the central nervous system. So they produce the central action on, that direct action on the central nervous system. So the next thing that I want to discuss and make sure that I feel like there's a lot of information. I was hoping to really keep it generally to about 20 minutes because it's very complicated. And for me, I really want to introduce this stuff to you all, but I'm studying it as I go. And I think it is just highly fascinating because these are compounds and constituents that have been around for thousands of years naturally occurring, and I do not have a degree in organic chemistry, nor do I desire to, but I just want to share information as I'm learning it. So this is the last big topic, and this is going to be a little funny because it's like mind-blowing to me. So if you are someone who's great, X and Y axis, we're not going to call them that, we're going to call it up and down. Okay, so we're going to say this is the up axis. It's terrible. Down, right? Horizontal, vertical, whatever you want to call it. So polarity is always on the bottom, and electronegativity is always going up. So polarity, electronegativity. So all constituents within these functional groups that we talked about that are within the compounds that we just discussed, they're going to be plotted along this chart because it's going to show us if they are going to be more acidic, more alkaline. It's going to show us where they fall. Their polarity is going to show how they would interact and what adverse reactions they might give to different living organisms. So those charts are, really important, and that's all the way down. We're talking like a gazillion levels down the actual product of what an oil is or could be. So I think that is very fascinating. It's something neat to learn about if you are interested in pursuing that farther and looking at how to plot them. What questions can I answer for you guys? I hope at this point that you have learned a few things. I would love to go into detail more and more about the process, like the vapor extraction and the different types of distillation. I will mention while I'm waiting to see if you have questions that I found it really fascinating about the extraction and distillation process to look at the science behind it and how a lot of times what is being done now is that we have solvents that are added and that's actually used to purify and break apart the oil itself, and then additives are added, and then it reconstitutes itself in another process. So that would be a two-step process that they would be using very high heat, very high pressure, in terms of distillation, and so the end product, all the additives that are in it would come up when you do that GC. So it all connects back together, and it can all be analyzed. But again, you would have to really learn and know a lot of these scientific terms to look into that. So I hope you have enjoyed learning along with me today. I plan on doing a couple of these. If you're not as nerdy as I am and you really aren't interested, that is okay. I hope some of you out there, if I have just one person interested and that can learn along with me, that is great. So next time I'm going to talk a little bit more about menthol, about terpenes in general, and I had one more thing on here. Oh, and the different types of esters, and then I'm also going to go into how that solvent process and how the different types of distillation occur, about cold pressing and a couple other things. So that is all for today. Unless you have questions for me, please let me know, and I will answer them for you. I'm going ahead and opening up the chat window. Well, thanks for spending time with me, and let me know what topics we're going to discuss next time. Listen to this again, try to take notes if you're interested in learning more about it. And again, thanks so much for your time. Have a wonderful afternoon.